Okay, the next piece that we're going to look at in chemistry is how we go about dealing with derived units such as volume. When we take the measurement of volume is something we're going to be doing a lot in the lab in this first chapter, and we want to talk a little bit about the whole concept of volume and where the units come from and how those units relate from the derived units to the units of liters that we use a lot in the lab. One of the main units we're going to use in chemistry is the unit of volume. You probably already know that the SI unit for volume is the liter. To define volume, we would use the definition as the amount of three-dimensional space that a substance occupies. We're going to find the volume of liquids in the lab frequently in this first and use the volume of liquids to find the volume of solids. We'll also find the volume of solids using length, width, and height. Volume is a derived SI unit. It's not a fundamental SI unit, one of the five fundamental units. It's something that's derived. It's obtained from taking the three dimensions, length, width, and height, multiplying them together. So if we have a cube, we would take the length times width times height to find the volume. So when we're doing volume units, it's almost similar to doing area units. You think of area is just two sides multiplied together. The common unit there is meters squared. That would be a derived SI unit. For volume, we're commonly going to refer to, once again, a same cube. Let's say that we have a cube that's 1 decimeter on a side. If we have a cube that's 1 decimeter per side, the volume would be cubic decimeters. And that is actually the definition of a liter. A cube that is 1 decimeter per side. That is a 1 liter volume. Now, we also know from the prefixes that we talked about yesterday that 1,000th of a liter is what we refer to as a milliliter. It's about the size of a sugar cube. Now this conversion factor you see right here, this equivalence, 1 milliliter equals 1 centimeter cubed. It's going to be very important that you know this relationship because we're going to work back and forth between centimeters cubed, the derived SI unit, and the milliliters, the other unit of volume. We want to be able to convert from liters to centimeters cubed, and this conversion factor from milliliters to centimeters cubed is the easiest one, I think, to memorize and therefore have all the conversions of volume that you can work with. If we look at this chart, you see all the different versions. A liter, which is actually the same thing as a decimeter cubed, and based on the prefixes, 1 liter is equal to 1,000 milliliters. A milliliter is 1,000th of a liter, 10 to the negative third liters. It's the same thing as a centimeter cubed. So there are 1,000 centimeters cubed in 1 liter. But just knowing this one-to-one, easy to calculate with, easy to use, this relationship between milliliters and centimeters cubed will be very useful throughout the course. Most of our lab equipment is in the unit of milliliters, including all the graduated cylinders we're going to be using. So milliliters will be our most commonly recorded value, and then we'll want to be able to convert that to liters, centimeters cubed, millimeters cubed, any other conversion that we would like.